Hey everyone, and welcome to our YouTube session here where we're going to take a look at TCS Ninja questions, that is, technical questions that have been asked in the interview on 14th of September 2021, that is today. We're going to take a look at the MCQs in terms of technical questions that have been asked, as well as the programs that have been asked, and we're going to try solving them here for you. So, without any delay, welcome to our Quant Masters YouTube video here on solving TCS Ninja questions. Now, as always, if you are new to this channel, make sure you just subscribe because we have tons and tons of content for you to go through. And before we start, I am Shashank, your technical trainer here from Quant Masters. So let us begin with the first question that has been asked in MCQs, that is for programming logic. Now let me just paste that question over here. So here's the question that we have. Let us go ahead and try solving this. So we have been given this question where we are asked what exactly will be the output of the program. So let's take a quick look at this and let's try to see how exactly we can solve this out. So if you take a look at this, let me just paste it again. All right, perfect. So if you take a look at this, let's start with the initialization and declaration here. We've got three variables. We've got I, we've got j, and we've got num. Three different variables. I and j are just declared, they're not initialized, whereas num is initialized to 4. So let us initialize num to 4. I and j, we haven't initialized it yet, so assume that they are garbage value. So we'll figure out what exactly are to be stored within it. Now, let's start with the for loop here. So we have a nested for loop. So if you observe, these are opening brackets. So this for loop is the outer for loop, and here you have the inner for loop. So for each iteration of the outer for loop, we're supposed to execute the inner for loop. So let us start with this. So in the outer for loop, we have our initialization where we are initializing I with 4. Let us do that. That's done. Now let's take a look at the condition. The condition is I greater than 0. Is I greater than 0? Of course it is. Since 4 is greater than 0, let us go within the for loop, that is within the outer for loop, to the inner for loop and perform the execution within the inner for loop. Now remember, within inner for loop, you have got that is within inner for loop, you have got only one statement, and the next two statements also belong to the outer for loop. Why do these belong to outer for loop? Because this is your opening brace of outer for loop, and this is your closing brace of outer for loop. So all the statements within this for loop basically belong to this loop of I. So since I is 4, I is greater than equal to 0, condition is true. Let's execute all these statements, where the first thing we have is an inner for loop. The inner for loop, we have initialization as j equals num. We know the value of num is 4, so let us initialize j to num as well, which is going to be 4 here. So once this is done, the next step is to check if j is greater than 1. Of course, j is greater than 1. Since the condition is true, let us print star. So I'm going to write the output here. We're printing 1 star. Done. After printing star, let's go for incremental decrement. We are decreasing j by 1. Let's take a look at the condition now. Is j greater than 1? Of course, 3 is still greater than 1. Since 3 is greater than 1, condition is true. Let's go to the inner for loop, print one more star again. Then go and reduce j value once more. Now j value turns down to 2. Is 2 greater than 1? Of course 2 is greater than 1. Since 2 is greater than 1, the condition is again true. So we're going to print the star over here. And we're going to go back and reduce the j value by 1 again. When we reduce the j value by 1 again, it becomes 1. The condition is j greater than 1. It's not j greater than equal to 1. Now j is no longer greater than 1. It's equal to 1. So condition fails. We stop this for loop right here. So we have printed star basically 3 times. So once this is done, the next thing is we're going to reduce the value of num. Let us reduce the value of num from 4 all the way to 3 now. Now that that is done, let's go for the next statement, that is printf slash n. So we're basically going over to the next line. When we go to next line, we are closing the outer for loop. That means we're going to have to go back to the loop once again. So when we go to the loop once again, we're going to do the same steps. Initialization is already done. Now this condition was checked, we executed all the statements here. Let's do the incremental decrement. We're basically supposed to decrease I by 1 to 3. So I'm reducing I by 1 to 3. So once that is done, the value of I is now 3 instead of 4. So when the value of I is 3, we're going to check the same thing. Is I greater than 0? Of course it is. Since 3 is greater than 0, we're going to go to the inner for loop where we're going to take j equals num again. J equals num, which is 3 this time. J greater than equal to 1. 3 greater than 1 is true. So we're going to print star. Then reduce the j value to 2. Then check again. 2 greater than 1, true. So print one more star. Then reduce the value of j to 1. Is 1 greater than 1? No. So stop the j loop. Go to the next statement where we are reducing the value of num by 1 to 2. Done. After that, this we are going to new line character. We're basically printing slash n. Let's go to the next line. In the next line, let's repeat the same thing. We're going to start with the outer for loop to be increment or decrement. So we're going to reduce the value of I from 3 all the way to 2 this time. When we reduce it to 2, we're going to have to go through the inner j loop once more. And what are we going to do within the inner loop now? Let's take a look at this. Within the inner loop now, j is equal to num. J is equal to basically 2. Is 2 greater than 1? Yes. So print a star. Then reduce j value by 1. Is 1 greater than 1 this time? No. So skip this. That is exit the inner for loop. Go to the next statement where we are reducing the value of number from 2 to 1. So after this is done, we're going to repeat the entire outer iteration once more. Remember, the j value now has been reduced to 1. So I'll just keep it as it is. So now when we go back here, I also gets reduced to 1. So is 1 greater than 0? Of course it is. So let's go within the for loop. Let's go here. For j equals num, the value of num is 1. J is also 1. Is j greater than 1? It's not true. Since it's not true, this doesn't execute. We directly reduce the number to 0 and we go to next line. So when we go to next line, in the next line, I value now gets reduced again to 0 because outer for loop all statements are done. Let's go for decrement part. So when you reduce the I value to 0, you look at this condition, it now fails. So because I is no longer greater than 0, it is equal to 0. Since the condition fails, we stop right there and your output is this. It's 3 stars, then 2 star, then 1 star. That is supposed to be your simple output for this program. Now, with this basic idea very clear, let's go ahead to the next question right away. So here's the next question we have, which is based on operators, that is based on left shift and right shift operators. Now, generally we think that when it's left shift or right shift, I need to take that number, convert it to binary, solve it, then convert it back to integer and print it and so on. That's our regular thought pattern. That is, I need to take something like 16 means 16, 8, 4, 2, 1. That means basically 1, 0, 0, 0, and 0. So this is the value I have. I need to perform left shift by 1. I need to perform right shift by 2. Then I need to convert it back to integer and go through. So there's a much easier way to do that. That is, in short, whenever you have a number left shift by n, you just calculate it as a multiplied by 2 to the power of n. Similarly, whenever you have a number right shift by n, you just calculate it as a divided by 2 to the power of n. That's basically it. So let's take this scenario here. Let's go for I left shift 1. So what's the value of I here? 16. 16 left shift 1 is same as 16 times 2 to the power of 1, which is supposed to be 32. So the first value to be printed will be 32 on the screen. Then we have something on right shift. So let's do that as well. Remember, first output to be printed is 32. Let's do the right shift. Right shift is 16 right shift 2, which is same as 16 divided by 2 to the power of 2, according to this formula, which is going to be 16 divided by 4. 16 by 4, we get it as basically 4. So that's why your output here is going to be 4. So your total output for this question, your MCQ output that you need to select for this question will be 3 to 4. As simple as that. Now, with this simple and clear, let's quickly move ahead to our next question that has been asked. So the next question goes like this. It asks, what exactly is the category in design technique that Bellman-Ford algorithm falls under? If you take a look at this, there are two algorithms that come up when you calculate shortest path. One is Bellman-Ford, the other is Dijkstra's algorithm. So when you compare them, Bellman-Ford algorithm always takes up your dynamic programming approach. So the simple idea is that whenever you go for Bellman-Ford algorithm to find the shortest path, it always ends up using dynamic programming approach. Whereas if you go for Dijkstra's algorithm, that instead uses greedy technique. So these are the couple of differences you can get to see if you go in depth within Bellman-Ford and Dijkstra's algorithms. But let's move ahead over to the next question very quickly from here. So let's take a quick look at the next program which comes up like this. So we have a function prototype here which reflects the function definition given here. So let's not worry about the output being an error due to function being called before the function is written. Now let's take a quick look at this. We're starting our main function. We are having a float variable called x declared. So I'm going to declare a variable called x. So I'm just going to divide this for our main function as well as the foo function. So in main function, we are calling the function foo here, where we are sending the value as 10. So let us send 10 over here, which is received here as an integer variable called I. So I will be equal to 10 over here. And what are we doing here? We are creating one more variable j, whose value is 5. Now we are performing j is equal to j divided by I. Now remember, this is a floating point variable. You're performing a floating point variable is equal to float divided by int. When both are integer values, your result will always be int. But here one of the value is floating point. So let's see what happens in this case. So we have basically instead of 5, you can call it as 5.0 divided by 10. When you perform this division, you're going to get 0.5 stored back in J because you are storing it in float value. And it's not just that we are storing in float value, we are dividing a float with an integer. If we divided an integer with an integer like 5 by 10, let's say both are integers, then the result will be of course an integer, which would be 0 on the other hand. But this time it is 0.5. So J will now be updated from 5 to 0.5. Now, what are we printing here? We are printing percentage 0.3f. This is the first thing that we are printing. What this means is you're supposed to print 3 decimal points. 3 decimal points after the integer. So the output will be 0.500. 3 decimal points after the integer. That is done. Once it is done, we are returning j. What's the value of j? 0.5. That 0.5 is returned back as a floating point variable. So it will return 0.5 itself. Where are we storing it? We are storing it in x. So what will be the value of x here? X will be 0.5. Once you receive the value of x here, you're printing it as 0.2x. 0.2 as in only 2 decimal points. That means, again, remember there's no space here. After 0.3f, we're not writing any space, printing anything extra. So we're just going to the next statement here, which is supposed to continue here, which is going to be 0.2f. That means 2 decimal points. That will be 0.50. So your output will be 0.500, then 0.50 followed by that. This is the output for this particular program. I hope that's very simple and easy for us to understand. Let's go for the next one. So here's the next question that we have, which is based on a recursive function technique. It's a very simple program based on recursion. Let's quickly try to solve this and see how well we're going to be able to work through this. So we have a main function over here. The function is written before main, so I'm just dividing them separately here so that we don't have any confusions. So we have a variable called t in main function whose value is 3. We are sending this t all the way over to call function. So call function is called on the other hand, it's aptly named as call. So when we call the function called call, we're going to send a variable whose value is 3. So call is called, in other words, with a value 3. This is done. Now, it is going to execute its first line. What is its first line? If n is less than 1. 3 is what is sent here as n. Remember, t is 3. When we receive it here, is 3 less than 1? Absolutely not. Since it is not, we're going to skip this if condition. We're going to go to the next statement. The next statement is performing one more call to the same function. That's recursion. So we're going to call the same function again by sending the value n minus 2. So remember this, we have performed call of 3, which is going to get paused here because the function which was called has executed first line. Since the condition was not true, it skipped second line, it is executing third line. This third line is calling function second time. So we have to pause our first function, which technically is put into function called stack, but I will state it here as it is paused. And we're calling the function one more time by sending n minus 2 as the value. So in short, let's say call of 3, where we sent 3 as the number. Let's say this is statement 1, statement 2, statement 3, statement 4, and statement 5. It is paused in statement 3. Let's assume it is paused in statement 3. Since it is paused in statement 3, we are calling one more time the same function, but this time we are sending n minus 2. What's the value of n here? 3. When you send n minus 2, what is n minus 2? 3 minus 2, that is 1. So we are calling the same function by sending the value of n as 1. When we send it, let's go ahead and take a look at this. Is n less than 1? Absolutely not. It is equal to 1. The condition is not less than or equal to. The condition is strictly less than. N is not less than 1. It is equal to 1. So we're going to skip this condition, go to the next statement. What is the next statement? We are calling one more function here. So this function where we are sending 1 as the parameter should be again paused at line 3 because we are calling one more function here where we are sending again n minus 2. What is n here according to this function? It's not a static variable in the function. So it's 1. What is 1 minus 3? Gives us minus 1. Sorry, 1 minus 2 gives us minus 1. After we get minus 1, when you go for this function, call of minus 1, since minus 1 is less than 1, it is directly going to return. That means it's going to go back. When it goes back, we have to continue from the third line. Let's go to the next line. We're printing the value of n. What's the value of n according to this function? It is 1. So output, I'm just going to write the first value printed is 1. Once this is done, let's take a look at the next line. The next line is again calling one more function. This time we are pausing this at line 5. Which function are we calling? We're calling the same function by sending n minus 3. What is 1 minus 3? Minus 2. When you call the same function and send n as minus 2, is minus 2 less than 1? Yes. So it returns. So basically no point in calling this function. It's going to go back here and we'll continue from the end of end of fourth line, not fifth. Where we go, end of fifth line. This is where we call it. Where we go to next line, where there's literally nothing, that's the end of the function. So this function gets closed. So once this function is closed, we're going to go back to the previous function call. The previous function call was when n was 3 and we had stopped at line 3 here. So let's go for the next statement. The next statement, we are printing the value of n. What's the value of n here? 3. We have printed it. Once that is done, let's take a look at the next statement. The next statement is call of n minus 3. That means we are pausing this function at line 5 and we are calling another, that is the same function once more recursively by sending n minus 3. What is 3 minus 3? Is 0. When 0 is sent here, is 0 less than 1? Of course it is. That means nothing will happen. It's going to return back. When it returns back, it will continue from the fifth line to the next line, which is basically close bracket. So your output is only 1, 3 in this program. So sounds like a very simple and easy program, really not difficult. So these are how you can expect very, very simple and easy programs like this. So let's quickly move on to the next question right away. So let's take up the next question, which is based on a 3-dimensional array. Now this may sound a little complicated if you look at this, but it's really not. It's a very simple program. So just to give a bit of a backstory within this, an array is just a pointer. When you talk about an array, the array name will always store starting address of the entire array. So if you can print the array name as %p, it's going to print the starting address of the array. That's basically how it works. So let's take a quick look at this and let's see how this exactly works. We have a three-dimensional array 2, 3, 2, which basically means the number of elements will be equal to 2 into 3 into 2, which is going to be 12 elements in total. If you take a look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's 12 elements in total exactly. So this is what we have here. We have a three-dimensional array of 12 elements. And they're asking us to print a of 1 minus a of 0 and then a of 1 of 0 minus a of 0 of 0. To perform this, you don't need to know the values at all. Even if you just declare it, you don't initialize it, your output will be same. How is that? Let me explain. So just to point out, if you have a one-dimensional array, the array name will store starting address. If you go to that starting address, you're gonna find continuous blocks of memory where you can store elements. This is a one-dimensional array. Similarly, a two-dimensional array, that is when you have a of I of j, it's not rows and columns. I is number of arrays and j is number of elements within each array. So if you write a of 2 of 5, that means there are two arrays with 5 elements each. So basically what that means is there are total 10 elements. And these 10 elements are divided into two arrays of 5 elements each. That is how two-dimensional array works. So if you're with me on this, let's move this up a notch to three-dimensional array. Now I'm just going to move away from the program so that I can have enough space to write the entire thing. So if you take a look at this very quickly, a three-dimensional array, like let's say for example, I have array of I of let's say j of k. That means there is I number of arrays which are then pointing to j number of arrays, and each of these j number of arrays has k number of elements. So let me write this down so that it's very clear. When we write this as a of 2 of 3 of 2, that means there are two elements in an array. So in an array, we let me write it down a little bit lower so that it's much more clearer for us to quickly understand. So if you take a quick look at this, we basically have an array of two elements. So let's start A here. This array A has two elements. Now what are these two elements? These two elements are array of 0 and array of 1. Both of these elements will store starting addresses. This will store starting address to an array of, guess how many elements? There's an array of two elements, and each of those two elements will store three elements. So let us store three elements here. I'll just write it as 1, 2, and 3. So same way, array of 1 is also going to store, let's say, three elements over here. That is 1, 2, and 3. I'll just write it a little below so it's very clear. Perfect. So now, what is this three elements gonna do? Each of these elements is gonna store starting address to an array which stores two elements on the other hand. So in short, you have an array of two elements, and this array of two elements is where each element will store three elements. If each element is storing three elements, this is again an array, and these are the elements of the array. But these are not going to store your integer elements or anything, because this is not the last index. This is the middle index. So that means these are three different starting addresses stored here, 1, 2, and 3. And these starting addresses are going to store arrays of two elements each. So this first index, which is going to be called as array of 0 of, let me just use a slightly lower size here to make it very clear. Let's say array of, again, I think this color may not suit this perfectly. I'll just write it here. Let's say this is array of 0 of 0, and this is array of 0 of 1, and this is going to be array of 0 of 2 on the other hand. Likewise, this will be array of 1 of 0, and this will be array of 1 of 1, and this on the other hand will be array of 1 of 2. So this is how we have array of 0 is one array which has 3 elements, array of 1 is another array which has 3 elements, and each of these elements is going to point to another array which stores exactly 2 elements. That's the basic idea. This is how you get these arrays. So I'll just point it out very quickly. So if you take a look at this, this is array of 0 of 0 of 0. Then this is array of 0 of 0 of 1 and so on. So this is how you got 12 elements in total. This is the representation of a three-dimensional array. Now what are we supposed to calculate? Let's take a look at the question. The first thing is a of 1 minus a of 0. Let's take a look at this. What is a of 1 minus a of 0? Remember, a of 1 stores what? Starting address of this location. A of 0 stores what? Starting address of this location. So what does array name always store? Remember, array names will always store address of the starting element. So array names always store, as we should remember, the address of the starting element. A of 1 will store the starting address of this, whereas a of 0 is going to store the starting address of this on the other hand. So let's take a quick look at how it works. So in short, this is what we have. We need to figure out what is a of 1 minus a of 0. Now take a look at this. A of 0 is going to store starting address of this, and a of 1 is going to store starting address of this. Now we know that in an array, all the elements are stored in continuous memory location. We know that, right? All elements are stored in continuous memory location. So think about this. Since this is, according to the question, an integer array. If you look at the question, it's an integer array. Let's take each integer takes 2 bytes. So this first element address, I'm just assuming, let's say the first element address is 100. If the first element address is 100, it will take 2 bytes. Next element will be 102. Next element will be 104. Next will be 106. Next will be 108. Next will be 110. Next, let's say 112, 114, 116, 118, 120, and 122. Let's say these are the addresses. Now, in that case, we are calculating what is a of 1 minus a of 0. Now, what is a of 1 storing? A of 1 is storing starting address of this array. A of 1 of 0. A of 0 is storing starting address of this array. If you look at this, from a of 1 to a of 0, how many elements are there? How many elements are there in a difference? If you look at this, you have to go back 1, 2, 3 addresses. You have to go back 3 addresses. Whenever you subtract a pointer with a number, with a pointer value like this, the result you get is not going to be a calculated number that is difference of addresses, like which will be some very huge random garbage value or something. The difference is the distance between those two elements. Distance between a of 1 and a of 0. In short, this is a simple way to understand. We are not going in depth about pointers to understand everything about it. To understand in short and simple, you can think of it like this. So similarly, if you calculate, let's say this element's address minus this element's address, even though the difference between address is 2, you're gonna get 1 because there's a difference of 1 element. So if you take a look at this, there's a difference of 1, 2, 3 elements. Since there's a difference of 3 elements, the output for this first case, that is a of 1 minus a of 0, will be 3. Then we have one more thing called a of 1 of 0 minus a of 0 of 0. Let's take a look at this. Here the output is 3. Let's take a look at the next one. The next one is a of 1 of 0 minus a of 0 of 0. If you take a look at this, what is a of 1 of 0 minus a of 0 of 0? If you take a look at the difference in elements, from a of 1 of 0 to 0 of 0, 1, 2, 3, 4, 5, and 6. You need to go back 6 elements to reach it. That's why your output here is going to be 6. If you really want to know in depth, like instead of the shortcut method, for arrays, if you really want to go in depth in calculating it, you need to know pointer arithmetic and perform the calculation. That's the basic idea. We're just calculating it in an easy way because we may have very short amount of time within interviews. So your output is supposed to be 3 followed by 6 because a of 1 points to this, a of 0 points to this. A of 1 minus a of 0 is this distance. Similarly, a of 1 of 0 points here and a of 0 points here. The difference in elements, distance in elements between these are 6. So you get 6 over there and 3 over here. So your output is supposed to be 3 and then 6. That is 36 in short. That's supposed to be your output. So this is the solution for this particular question. Now that we are done with this, let's move on to the next question, which is again a very simple question that asks what is the output. Let's paste this. It is more of how we can basically say that it's more of a pseudo code question where it looks like a programming language code with some operations, but it doesn't resemble any programming language. So let's quickly take this up. So this is a very simple and easy question. So we have three integers. One is called coins, which is 15. Then we have another variable called split, whose value is 3. Then we have one more variable called rest. Alright, so we are first performing minus minus coins. That means we are supposed to subtract coins by 1. So instead of 15, I'm going to make it 14. Done. Once this is done, we are performing rest equals coin modulus split. So let's perform coins modulus split. Coins value is 14, modulus split value is 3. That basically becomes I need to divide 14 by 3 and I need to get the remainder since it is modulus. So 3 times 4 I can get it as 12, the remainder is 2. Since 2 is less than 3, we don't continue any further. If you use division symbol, you're going to get this quotient. If you use mod symbol, you're going to get this remainder. So we're going to get this remainder, which is 2, which is stored in rest, and we are printing the value of rest, which is supposed to be 2. So a very simple and short program. Your output here is going to be 2. Now with this done, let's go for the next question very quickly. So the next question is a very simple question that tests your basic skills on operator precedence within C language. So let's take a look at this. We have two variables, A whose value is 4 and B whose value is 2. So we have three expressions, exp, exp2 and exp3, which we are printing in the exact order. So if I calculate them, I just have to write the same thing as the output. Let's do that. So here exp is bracket of A plus B divided by B. So let's quickly try calculating this. So let's quickly take a look at this and let's see how it works. So whatever is in brackets has the highest precedence, and associativity of arithmetic operators is always left to right. So let's work on this left to right. So first I need to start from left to right. That is, what is A plus B? We have 4 plus 2 and then divided by 2. So 4 plus 2 in bracket, we get it as 6, which is a single element, divided by 2. Again, always left to right. So we're calculating whatever is in the left part. For 6 by 2 gives us basically 3. So the first variable value that we get as the output is, in short and simple, 3. Done. After that, we have one more thing, exp2 equals A plus B by B without any brackets. Now, if you take a look at this, when you're working on this left to right, we generally assume that, you know what, I'm going to do A plus B first. I'm going to perform 4 plus 2 first, which is supposed to give me 6. After getting 6, I will divide it by 2, which is supposed to give me 3. But if you calculate this, it's not going to happen in such a scenario. So let's take a look at this very quickly. Remember, even though associativity is left to right, precedence also matters. Precedence or importance of division is higher than addition. Since precedence of division is higher than addition, your compiler basically puts a bracket in these division steps by itself. That is what it does. It puts brackets in these steps automatically. So when it does that, you basically get A plus bracket of, instead of A plus bracket of B by B, I'll just write it as 4 plus bracket of 2 divided by 2, which is going to be again executed left to right itself. It's going to calculate 4 plus, and it realizes that there's a bracket, so it must be a single element. It calculates the result of this, which is ending up to be 1. After it ends up to be 1, it takes that value 1, then realizes it has to perform 4 plus 1, which is 5. That's how we get the output as 5. Now, if you take as exp3, it's literally not different than the previous exp2 operation that you've done. The only difference is in exp2, they're not giving you the division symbol. Sorry, they're not giving you the brackets. For exp3, they're giving you these brackets explicitly. That is the only difference between them. So they basically make no difference. In short, it is going to be 355 itself, because whether you give brackets to division or not, by default, since division precedence is higher, brackets are gonna be added to division only. So that's your question here. So with this solved, let us now go on to the next question. So this is a very easy and simple question that can help us understand something about stacks. And if we know this very simple knowledge of stacks, it's very easy. So we know that a stack is basically an array where we insert the elements from one end and we remove the elements from the same end. So we generally consider something like this. We generally assume that it's a vertical stack. We generally learn it from a vertical point of representation. But here they've given it as an array. I will explain it as the representation in memory horizontally as it's supposed to be. So we have multiple elements. Let's take it as 4, 7, 8, 1, 4, and there's one more value here. Let's add the rep as well as 0. So this is my index 0, 1, 2, 3, 4, and 5. So remember, in a stack, you always enter the elements from the top of the stack and remove the elements from the top of the stack as well. Bottom of the stack, the last element will not be removed. And there's an indicator value called top, which always points to the index of the topmost element. So what are they telling us? The question is, what is the top element? Top element currently is 0 because top index is 5. That is the topmost element. Now, what is the top element of the stack created from the below array? That is this particular array, along with one pop element. That means when you remove one element, what will be the top? If you remove one element, which element will we remove? Will we remove the element that we entered first at index 0, or will we remove the element that we entered last at index 5? Of course, we'll remove the element which we entered last at index 5. When we remove that particular element, so just ignore that the 0 is there. I'm just gonna lasso it out. Perfect. So once we remove that element, this is now going to be your topmost index, 5. So which is the top element in that case? That is 4. So your output here is supposed to be 4. We always remove from the end where we insert. So remember, top is -1 by default. We increase top 1 at a time. That's how we indicate it in this order. This is a very simple question that we have here. So with this, let's go for the last question that we have. I think it is it is the last MCQ question in programming logic that we have. Let me just paste it here very quickly. So this is our question. Let's take a look at this. And this question is also related to stacks itself. So the question is like this. Neil tries to pop the following stack. What is the following stack? Here's the following stack. P is the last element, O is the middle element, T is the first element. So I will indicate it like this. So I will indicate it as a stack like this. We have P, O, and then T. So P is the topmost element, T is the first element inserted, P is the last element inserted. So the idea is Neil tries to pop the following stack. If he's popping the stack, what is the sequence he will receive? So whenever you pop the stack, you remove the topmost element first. Then you remove the next element. Then you remove the next element. Because each time you remove the element, top will get reduced by 1, pointing to the previous element. and so on. So at this point of time, stack is empty, you can't remove any elements. So the sequence in which you got the result is pot. So your result here is supposed to be pot. So this is your simple solution for your problems here. That is programming logic, that is MCQs. There are 10 questions were asked, and we were able to solve all 10 very, very clearly, very, very quickly, and very, very easily. With this, we will end our session on programming logic here. We do have more sessions on NQT and various other things. So if you're interested in going through them, definitely check out our channel, Quant Masters channel. And if you want to know more about a lot of technical reasoning, verbal, logical, quantitative aptitude, we've got a lot of material, and we have a special program as well that we conduct. For more information, just check out the description of our channel. So thank you for joining in. Have a good time.